which is a way for us to evaluate on paper what expressions are going to do. So the first thing I'd like you to do is to recall the second mantra from yesterday. Anybody memorize them yet? Oh, you're reading it, you're reading it. I see. Okay. Define the value. That's okay, I'm reading it too. Of a combination. I know it, I just don't know the official word. Okay, what's the first thing we do? Find the value of a combination. Right. Find the values of the subexpressions. How do we find these values? Right to left, left to right, randomly? Any order. With modification, unless it's a special form. Because recall, special forms have special rules. Okay. Second step.
Evaluate.
We need to evaluate it, but we apply. Apply the value of the first to the values of the rest. Okay. Like that. Let's write a procedure to calculate the absolute value of a number. So I'm going to call my procedure absolute value. Recall that for the first couple of lectures we are going to break this out into this lambda expression. And I'll start taking the shortcut probably tomorrow. We'll start going to the sugared expression. Okay, if I'm taking the absolute value of a number, how many parameters am I going to have?
One.
Let's name it n. What do I want to do in the body of my procedure?
We need to check if that's positive or negative.
I hear a positive, negative check. Right. Okay, good. If, let's check if it's negative. If n is less than 0, if it's negative, what do I need to do?
Make it negative.
I need to negate it. Minus n. There does need to be a space between the minus and the n. So you're basically doing subtraction on one number, which is negating it. If it's not negative, return it. Okay, so that's our absolute value procedure. And let's run the substitution model on absolute value of plus 3 and minus 8. Now the minus sign and the 8 come together. It's a constant, it's just like writing a normal number. Now that we've found the values of all the sub-expressions, we apply the first, add to the values of the rest, giving us minus 5. Okay, let's find the value of this sub-expression. Well, this is a procedure of one argument whose body is if n greater than 0, n rather minus n. Space. Sorry, yeah, less than. Okay. So now we found the values of our two sub-expressions. To apply our procedure to the rest, this is where the word substitution comes in. We're going to take this and substitute it in for every occurrence of n in our procedure. So if less than negative 5, 0, negative, negative 5, it's our substitution step. We substitute 4 parameters for procedure. So now we need to evaluate the if expression. Am I going to go through and figure out the values of all the sub-expressions right now? No, why not?
Let's do the one which corresponds to whatever.
Special form, right? If is a special form, so therefore we need to follow special rules for evaluation. And for the if, it says the first thing we want to do is evaluate the predicate. So we go through 0, -5 is already evaluated. Apply less than to 5 and 0, which is true. Our special form says that if the predicate is true, we then evaluate the consequence. So let's evaluate this. -5 is already evaluated. This negates, giving us 5, which is the return value. If I had a little more board space, the 5 would be on a separate line from true. Questions on this? Yes?
Is that actually how it's done, or that you actually substitute in the computer does that? Because I guess for example here it wouldn't be necessary to substitute some of the things in.
The caveat is that the substitution model is merely a model for us to think about what Scheme is doing. But in fact, Scheme will do that substitution when it's called. Okay, but this is a model for us to think about. Scheme may not be doing it exactly the same way that we're modeling it here. It's close to what Scheme's doing, but may not be exactly the same. Other questions? Okay. Everybody's memorized this.
Could you just go through and show me an example of when you do and do not put brackets around n or parentheses around n?
Find x to be 3 and y to be lambda, no parameters for 3. So, what if I want to get x to return a 3? What would I type in and evaluate? If I wanted to use y, could I just say y? What would it return if I said y and then evaluate? Yeah, the procedure, blah, 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 like gobbledygook. To apply the procedure, we put the parentheses around it, and then it would return 3.
So only when y is the name of a procedure or the name of it's a name as opposed to a...
If we've defined a variable to be a constant, we're not going to put parentheses around it. It doesn't make sense.
Okay.
Because we can't apply a number. A number is not a procedure. Okay, but if we've defined y to be a procedure, and spell lambda correctly, then we can apply a procedure with the parentheses around it. Yeah.
Why is it the consequent you have to write minus n in parentheses, but you don't have to write -8 in parentheses? It seems a bit good.
This is actually a constant value that's in this scheme as -8. The numbers are represented. So you have -3, -4. But when you're using the name of the variable, it becomes an operator on the variable.
Okay.
So that's why we have it with the operator space and then the variable name. Yes?
Are empty parentheses allowed after y? Paren y, open close paren, close paren? It does have 0 arguments.
Actually, so could you just say again what you're trying to ask?
Y has no arguments.
Y has no arguments, correct?
Could it be called, if I can use that term, with no arguments, with actual open close paren?
You don't put arguments in
No,
parentheses.
that's a C'ism.
Okay.
In Scheme, we denote no parameters by just not putting anything after the name of our function before the closing parenthesis.
Yes.
Okay, so no, you don't put the friends like that.
What is a C'ism?
If you know the computer language C or Pascal, when you're calling a function or procedure with no arguments, you give the name and then you put parentheses with nothing inside of it. So I'm saying it's a C'ism because if you programmed in C before, that's something you'd be thinking about doing.
I'll erase that.
Yes. Erase the C from your mind.
Well, also, unless the argument for y was an expression, you wouldn't put it in parentheses anyway. You just write it right next to the y.
If it were a variable that evaluated just to a constant, sure, we would just write y. We
Or
wouldn't
if
be
it were a
applying it.
constant or something. In other words, whatever arguments you're feeding to y, unless they're an expression, they don't go in parentheses anyway. So. Never-
Right, but they would still go here. They may not go in parentheses.
Right.
But
So you could show y in a space or something.
sure,
That would
sure, we
be
could put a
more
space
analogous.
there, right? It'll just crush out the white space.
Illogical.
If you wanted more white space, you could put it there. Yes.
And I'm a little unclear on the use of lambda. Is it just another function?
Lambda is a special form. It's one of our 15 special forms. This particular special form creates a procedure. And there's two parts of lambda. This first part here is the list of parameters. In this case, we have just one. If you wanted more than one, you would denote them just with spaces between them, no commas or anything like that. The remainder of the lambda is its body. Okay. So it's just one of the 15 special forms. So lambda creates a procedure for us.
Okay.
So what does it mean with has no parameters?
It just means it's a procedure that takes no variables into it. There's no information that you need to pass into that procedure for it to do anything that we want it to do. If you want a procedure that returns the number 3, we don't need to pass a number in. It's always going to return the number 3. So it doesn't matter if we pass in the number 1 to 312. We just want it to return the number 3, and we're not going to operate on any number that we would pass it. So there's no reason to pass it a number. We have no need for any variables inside that body. We don't need to pass it anything.
Is there any difference between, say, lambda or define in the first line, the line you wrote? Is it define and?
Which one? This?
Yeah. Yeah, yes.
So is there a difference between lambda and define?
Yeah. You don't,
Define is another special form. We talked about it yesterday. And define is a special form that allows us to name an object. So, rule for that is define the name and then the object. So in this case, ignoring that because it was a separate example, we define the name absolute value to be the object, this object, which is a procedure. Okay. In this case here, we're defining x, the name x, to be the number 3. Okay, so it's just one of our special forms. We have special rules for evaluation of
what
those.
will happen if you delete the word lambda, and just leave the thing as it was? The first one, yeah.
What's going to happen here?
Parentheses. It's gonna be
Well, what it's going to do is define, it's going to bind this name to this stuff here. And Scheme is going to try to evaluate this. So it's going to try to find the value of apply n. It's probably going to be unbound in our environment, or if it is bound, it's probably bound to be a number. And most likely will not be bound to an operator, and we're going to end up with an error. So you need to have the word lambda there. Yes?
Is there a special style for naming variables and procedures? To make up the names, is there some style for
You should definitely name your procedures something that describes what they're doing. The internal variables and procedures, some people go with the school of ABC, MN, OP type of variables. Some people try to make them longer. I don't know. I suppose if you name them something that sort of makes sense to what they are, it makes your code easier to read. In this case, we're just taking in a number. I denoted it by n. I could have written number, but just shortened it to n. But you should certainly, this name, you shouldn't name your procedures things like procedure 1, procedure 2, procedure 3, because then they're not going to be useful for you, and for people reading your code, they're not going to know what you've written.
And you don't have to declare your variables at the top of the block.
That's another C'ism. Be gone! Get out of the room! Not you, the C'ism.
Yeah, but doing that, you often comment, you know, declare blah, 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 integer comment, what that is. I haven't heard any talk about commenting and documentation and scheme.
Okay, if you like comments, that leads a comment.
Oh,
Okay,
okay.
in Scheme, if you want to write comments, which are fine things to write, we don't concentrate a lot on them. You start with a semicolon, and then you write your comments. It can be at the beginning of a line, or it can follow a line of code. Actually, comments are a good way when you're writing in your answer buffer that you're going to be turning in if you want to write some answer to an exercise and then have some code. Because if you want to go in later and evaluate the entire buffer, let's say you're working on your problem set over a number of days. So you got your answer buffer, you come in the next day, you want to evaluate it, so you're in the state that you were the previous day. Make sure that you comment out any text in there with comments, because then the next day you come in, load that file, and then do meta x eval current buffer. Suck all that code back in. So that's one good thing that comments are useful for.
Are there multi-line comments in Scheme?
Semicolon, semicolon, semicolon. It's one character to type. It's not that bad.
But if you have like
Come on,
a
use a pinky.
5-line comment or something, you're like,
Meta X comment region.
Mid-X comment region, does it work?
Yeah.
no.
I'd rather hit the semicolon 5 times myself. Fewer characters. Okay, other questions? I erase this board. Yes, Sean?
I just had a comment on Teresa's question before she asked about, you know, having just the end by itself or the end with parentheses around it. So if that causes confusion, I mean, it's really it's a complete choice, right? We could have made Scheme automatically evaluate everything as a procedure and then put a special symbol if we wanted to have it not be a procedure, right? I mean, it's
Sure.
right. I mean, other languages do that. So it's arbitrary to do it, but once we make the decision, Teresa, then you have to decide.
Okay. And in a few weeks, when we learn the Metacircular Evaluator, if you want to rewrite Scheme to do it your own way, we can do that. We can rewrite Scheme to do anything we want. Oh, we will. It'll be fun.
The weeks go by fast.
What I'd like to do now is write a procedure to compute the distance between 2 points. X1, Y1, X2, Y2, formula given by
X2 minus X1 squared. X1 minus Y1 squared.
Does it matter if we do X2 minus X1 or X1 minus X2? No, because we're squaring it. Drop the sign. Okay, so what helper procedures, what things might we need to do? Square and square root. Square root is a primitive procedure. It's defined for us in Scheme. Square root of x returns the square root of x. How about that? True, see, true. In any case, that's what square root does. Actually, the book goes through a long discussion of how we could redefine square root based on Newton's method. So we could redefine square root, but it is actually provided for us in Scheme. Okay, so we'll need to have square root. You might want to have a squaring procedure. So let's define square. I wasn't going to do that. Lambda x times xx. Okay, and then we're adding 2 squares together. So let's write a procedure called sum squares. So we're adding 2 squares together. How many variables? 2. Lambda xy. Add the square of x with those two helper procedures, then we can define the procedure distance between 2 points. How many parameters here? 4. And let's call them x1, y1, x2, y2. So what do I want to do in the body here?
Square root.
Take the square root of the sum of the squares, some squares. And here, x1 minus x2. y1 minus y2. So in this sense, in this case, we're actually writing the procedure. As we said before, it doesn't matter which way we go, but that's what's actually written in the code. Some squares, square root, lambda, divide. That's the, I ran out of space parentheses there. Okay, let's evaluate this using the substitution model. So we're going to compute the distance between 2 points of 1, 1, 4, 5. So 2 points of 1, 1 and 4, 5. So evaluate sub-expressions any order. x1, y1, x2, y2. Alright, I'm writing the body right now, just put those dots. Finish evaluating our sub-expressions. To apply the first to the rest, we're going to take these values and substitute them in for the variable, substituting in 1 for x1, 1 for y1, 4 for x2, and 5 for y2. And we'll have square root, some squares, minus x1 is x2, y1, wait to say it, y2. Okay. Now, again, to evaluate the value of the combination, we're going to evaluate the sub-expressions. There's one sub-expression here, and a sub-expression there. To evaluate this sub-expression, we're going to evaluate its sub-expressions. There are 3 of those. Some squares, minus 1, 4, and minus 1, 5. Any order. Subtract 1 and 4, giving us minus 3. We're going to subtract 1 and 5, giving us minus 4. Okay, and then sum of squares is a procedure, takes in x and y, and adds the square of x to the square of y. Again, to apply this, we're going to substitute negative 3 for x, negative 4 for y, giving us plus square minus 3 square Yes? Question? To evaluate this, we have 3 sub-expressions. Let's do add first. Okay, so square is a procedure, takes one argument, multiplies it by itself, divides -3, gives us times -3, -3, times goes to multiply, and this gives us 9, way there at the bottom of the board. Okay. Similarly, over here, procedure x times xx minus 4 gives us times x, -4, -4. This goes to multiply way there, and then we ran out of space. Gives us 16 on our infinite board, somewhere down here. Okay, I'm unfortunately out of room. What's that? Let's move. Let me copy what we have standing. We're still waiting on the square root. And we are, at this point, we have the plus. Actually, I've already evaluated that to add. 9, 16. Apply the first to the rest. 25. This is the primitive procedure square root. Conveniently enough, it came out even. Long, gory. That's the substitution model. Yes?
Is this something like what the debugger does when it tries to find the root of the problem plus abstraction, I guess?
In some sense, yes. So basically, you can think about every step that we're doing or deferring. We're going to put something on the stack. And what the debugger is showing us is a stack of evaluations, right? So if you went on the debugger and you looked at the root of it, at the very bottom, it's going to give you the first thing that we were evaluating. In yesterday's case, fold 1, 2. The next step up is going to be the expansion of fold 1, 2 into times, spindle, mutilate, whatever that was. And then it showed on the next thing, the sub-expression of that it was evaluating, which I believe was spindle in that case. And it went up. So the bottom of it was the first thing that was evaluated, and then went up to where we were. So you could think about maybe this would be the bottom of our stack, and then we'd be going down one piece of it here. Any other questions? Okay. I'd like to talk about a little bit our definitions here. What I want to talk about is block structure. That's in the book, some of you may have already read it. In this case, we've defined square and sum of squares, which are procedures used by distance between 2 points. In this case, we've written the 2 procedures separately, meaning that any other procedure we write can call them. Okay, these are out in the external environment, our main environment. So we can call them, we can write procedures that call them. But what if we wanted to hide these procedures from the rest of the world? We just wanted them to be used by distance between 2 points. How could we rewrite that code?
We could define them within the body of
Right.
distance.
We can define them within the body of the procedure distance between 2 points. That's for this.
So is the benefit of block structure that it's going to like free up RAM
that, you know, if we had all these other things run as separate procedures, they would always be saved in the environment?
They're always going to, so when we evaluate, when we do this define, there's going to be a little lambda procedure hanging around. When we go to evaluate that, we will, this is the environment model, where we're getting ahead of ourselves here. A little bit too much. The main reason for doing this would be to hide them, to not clutter up the environment. So here we would define square. And we would define sum of squares. So here, we've taken these two procedures and defined them internally. Now in this particular case, we could make an argument that the square procedure and the sum of square procedures are actually, they could be useful. These actually might be things we'd want to keep out in our environment because there's probably other procedures that we're going to want to use squaring in. And there might be other procedures we'd like to sum our squares. So in this particular case, we may not want to hide them here, not really hide them. But if we put them here, they can't be used outside the procedure. Whereas in this case here, they can be used in the global environment. Our main scheme environment that we're running in. In the book, you'll see an example of finding square roots by Newton's method. Okay. And in that case, they've got helper procedures, good enough, square root iter, things like that, that we probably would not want to have in the external environment because they're really very specific to that procedure. Whereas in this case, they would probably be more useful out in the global environment. So just something to think about when you're writing procedure. If you're using helper procedures, if you're calling other procedures, you should think about, are these things that might be useful out in the environment that I might want to use in another procedure, or are these very specific to the code that I'm writing for this particular procedure? So that's, and the block structure. Yes?
If for some reason you decided to define some squares before you had defined square within distance between 2 points, would it have returned an error? Or would it? Because there's no order, right?
Right. So basically what's going to end up happening is when we create an environment, and we'll see this very clearly when we get to the environment model, there's going to be an environment for this particular procedure. And these two things will be defined in that environment. So when we go to do the body here, those two things have been defined in the environment.
Mm-hmm.
Okay, so they'll be there already for us.
Okay.
It doesn't matter if you flip them.
No. Yes?
Could you do a nested square inside sum of squares?
Sure could. So the question is, could we actually here nest square? And we could. In this case, we're not calling squares here. So if you wanted to, you could have nested that. I'd actually...
By nested, you put the definition.
We could define it here, just like we defined these within the body of the lambda here. We could have defined this within the body of this lambda here, nesting it down one more level.
If you did that, then distance between 2 points would not be a square.
Well, then some squares would know about squares.
Right, but if you wanted to...
Right, but this procedure here could not call square. Yes?
I still don't see what you gain from doing it, or what's the problem with having it outside.
The gain is mostly that the external environment just isn't getting cluttered up with all these names. There's the stuff lying around that people could use that you probably don't want them to be using.
Well, in the case of having, the further out you go, depending on how complicated your environment gets, if you have a very common name for something, then the chance, there becomes a chance that you have two things with the same name. Is that?
That could be one thing too, right? You may name a procedure the same thing. If you're controlling your environment, most likely you won't. But maybe if you're sucking in code from somebody else, you might be.
For portability's sake, it would be useful to have all of your sub-procedures defined in your procedure too, so you could reuse your code, right?
Certainly, because then you could take this chunk and reuse it. However, you could argue that I could also pass you an entire file of code, right? I don't need to, if we're moving our code from one machine to another, you don't need to just take one procedure, right? We could take a file of code. So for portability's sake.
But for reuse of code, like you would program this and then for your simple physics then.
In Lambda, are you allowed to define these things wherever? I mean, it's essentially serving as another parameter in the Lambda right now.
No, it's not. It's
'Cause
not another parameter. These are the parameters.
Okay, that's right, not as a parameter.
So it's at the start of the body of the Lambda. And you want to have them at the start of the body of the Lambda.
But they're, okay, so they're enclosed in their own.
So it's just its own statement, right? This is just, this is like saying plus x1 plus x, plus x1 x2. It's just another statement that we put within the body of the Lambda. But you are going to want to put them at the start of the body of the Lambda because it wouldn't make any sense to have them later. Because you'd be trying to use them and they're defined later. You need to define them before you can use them.
Because they have nothing to do with the arguments specified in the Lambda. The way they're carried out doesn't matter. The way they're carried out has nothing to do with what is fed into the Lambda. Okay.
They could have something to do with what was fed in the Lambda.
Well, their variable, in other words, they don't incorporate x1, y1, x2,
They
y2.
could.
Sure, they could. But it was kind of weirding me out that they would be inside a Lambda expression where the whole point of a Lambda expression is to take this input and do something with it. And I was thinking, well, why wouldn't they react differently?
Well, but they'll get input from later on down here.
Well, yeah.
But it's basically at the start of the body is where you're going to want to define your procedures.
You may have said it, but you could do them otherwise.
Yes, you could do them otherwise.
If you do put x1 there, is that going to have to be the same x1 from the original Lambda statement? Or because it's in a new define, can it be any x1 you like?
This is for variable scope, okay? If we were to put x1 here, because we're not passing in anything called x1, this x1 is going to be the x1 scoped within this procedure here. Okay. Now, if I were to call this x1, it would become a local x1 here.
But then the x's wouldn't be defined. But then the x's wouldn't be defined.
But then the x wouldn't be defined here, right? So if I said x1 here, then it's not going to know what this is. Other questions?
So Holly, just to clarify, you couldn't take those two defines and put them after square root, but within those two defines, you could flip-flop them.
Okay. So the question is, could I take these two defines and put it after the body?
Right.
That's the first part of the question.
Yeah.
Does that make sense? If we were to try to use some squares before we defined it, we'd have a problem?
It doesn't make sense, but then given the fact that earlier I asked, could I use some squares if I haven't defined square yet? You said,
Well, remember, the lambda is a special form, and it's not going to evaluate the body of the lambda until we go to apply it.
okay.
Okay? So even though, let's say we define square afterwards, and it was defined here, the lambda doesn't care. It's not looking at the body of it until we go to apply the body of that procedure. And we're not going to go to apply it until we get down here, which means square would have already been defined in our procedures environment.
I see. Because you haven't applied.
Right. So the body of a lambda is not going to be applied and not to be evaluated until we apply that lambda. That's part of the special form. It says we're going to wait until we actually apply it, then we evaluate the body. And if you guys are working on problem set 1, you saw this when you defined square. You defined square and we had to intentionally put a typographical error in it. We had to put the time sign right next to the x, and you defined square and you got no error. And then when you went to apply square to a number, that's when it gave you the error because that's when the body was being evaluated.
if for some reason I'm writing a program and I've got the distance between 2 points procedure here, and I want to do a different sum square somewhere else in the program that does something different, I can do that right in this case, and it won't return any errors.
You mean if you want to write a different procedure here, or?
If somewhere else in the program, other than the distance between 2 points, if I want to do a different sum square.
Oh, sure. If we want to do a sum square here by doing, we could call it sum squares and we can multiply them.
Yeah.
If that was external, and then you have this definition internally, they're different. This is the locally scoped one. This is the one that's used here. If you're using from the outside environment, this is the one that will be called.
What's the opposite of locally scoped? What's the internal?
In the global environment. I mean, there's no real term for it.
We'll get into those issues.
With the environment model, we're getting a little bit ahead. Alrighty. We've been talking about the substitution model. As I erase one board full of it. There are two ways that we can evaluate the sub-expressions in our combinations. The first is called applicative order. With applicative order, we evaluate the arguments then apply the procedure. With normal order evaluation, we fully expand then reduce. Which means that we don't evaluate the operands until they are needed. Which one does scheme do? It's louder, louder. Which one does scheme use? Applicative, right. For the most part, except for special forms, right? Special rules. So we evaluate in order. We're going to evaluate everything, all of the sub-expressions, and we do our application. So to see the difference between the two, we've already done a large substitution model that used part of sum of squares. Let's just go through what sum of squares would look like if we were doing normal order evaluation. Label it as such because it is different from the scheme, from the normal substitution model. So let's do sum of squares. Plus 5, 1. 10 times 6, 2. So, I'm not going to go through the extent of the formality that we were going through the substitution model. Sum of squares is a procedure that takes in two arguments, x and y. This is x, that's y, and adds the square of x, square of x, times the square of y. haven't evaluated this or that. We're going to wait until we need it. Right now, we're just going to substitute that expression in. This expands out to times plus 5(1) plus 5(1) times 6(2).
Wait, I'm a bit confused already.
Mhm.
Some squares at the top takes as arguments.
X and Y. This is the same sum squares we had defined before.
Yeah, okay. But why is there times for y?
Y at the top is the
Oh,
what?
okay.
At the top what?
What represented by the time sign 6(2).
So this expression here will be evaluated to get the value for Y. This here is the value that we're passing for X. But with normal order evaluation, we're not going to evaluate the sub-expressions until we need to use them. So we're just going to substitute those in, which is what we did here. We took these two, substituted that for X in the body of this procedure, and this for Y in the body of the procedure.
Okay.
So we're delaying the evaluation until we need it. Now we've fully expanded, and we actually need these values. Now we need to start computing them. Plus 5(1), 6, 5(1), 6, times 6(2), 12, 12.
Is it again done in any order? Is it in any order when you?
This isn't scheme.
Doesn't it?
Right, this isn't what scheme is doing, so I'm not being quite as pedantic with the any order. If normal order were implemented in scheme, then we would say, once we get to the point where they need to be evaluated, then we would probably say we would do them in any order, because in scheme, the order of the evaluations isn't undefined. But scheme doesn't do normal order. That's why I'm being a little less formal about this one. Plus 36 and 144. Giving us 180. What's one potential problem, not problem, but what's not so good about normal order? What's one drawback here?
Unnecessarily.
Right, we're doing additional work. We're doing additional work that we might necessarily need to do, because here, by passing in the expression, we end up needing to evaluate that expression twice, instead of the once that we needed to do in applicative order. Similarly, with this expression times 6(2), we did it twice instead of the once that we would have done with applicative order. So, how would we figure out if our system was using applicative or normal order? Well, for any non-degenerate procedures, you shouldn't be able to see a difference. However, for degenerate procedures, we can. Let's write a procedure. Define P, lambda of no arguments, called P. What does this do? Isn't that beautiful? You would never write code that looked like this, right? What happens when we call P? It calls P, and it calls P, and it calls P, and it calls P, it calls P, and we have an infinite loop. This is an infinite loop.
Is that why it's a degenerate?
Yeah, we probably wouldn't write infinite loops in our code. Not on purpose. So let's say we wrote an infinite loop. What we want to do is we want to figure out if we're running in normal or applicative order. So let's write a procedure called test. And test is going to take in two arguments, x and y. And the body is, if x is equal to 0, I'm going to return 0. Otherwise, I'm going to return 1. Then, let's call test with the parameters 0 and an application of P. So, what happens? How about applicative order?
Is the P the same P as the both?
It is the P defined up here, yes.
What's your, that last line there,
Test 0, open paren, P, close paren, close paren. It's a call to the procedure test, where it's passing in 0 as the X argument, and application of P as the Y argument.
In applicative order, it will stop after the first step because it presses zero. Stops at constant.
Well, remember, what we're first evaluating is this. And what's our applicative scheme rule? Evaluate all of the sub-expressions in any order. When we go to evaluate all of the sub-expressions, what happens? We get an infinite loop. What happens with normal order, where we delay evaluation until we need it? We pass in 0 for this, P for the Y, but we never evaluate it. Here we check, is X, which is 0, equal to 0? And it is, we never evaluate the Y. So with normal order, we return a 0.
I'm not quite sure why what's happening.
Let's go through a substitution model on P.
What?
Let's go through the started one, because I'm just not going to stay here all day. And all night until tomorrow. All right, so P, evaluate sub-expressions. Well, we got one. It's a procedure that takes no arguments, calls P. We apply P to no arguments, which results in a call to P, which is a procedure of no arguments. Say call to P, which is P, which is a procedure of no arguments. Anybody doubt that this is ever going to end? Not going to end, rather? I could go on for a while, but it's an infinite loop. It's going to keep calling itself. It's never going to come out of there. So that's what P is doing. And because we've created a procedure that does something that you normally wouldn't create a procedure to do, it allows us to see whether we're using applicative or normal order. Normal order, we're never going to evaluate that P. We're going to pass it in as a parameter, but because the if doesn't need to use it, we're never calling that infinite loop. We never go off into loop land. Yes?
Is it called normal order because across computer languages as a whole it's more widely used? Or not? Because applicative seems more rigorous.
I actually don't know the history of the names, but I don't think it's normal because it's not.
They're theoretical terms.
Yeah, I mean, it's.
So with normal order, you're traversing the tree first branch first, or rightmost way.
If you get rid of the parenthesis on the P, would that end the infinite loop? Or?
What would happen there? What would it return? It would return a value, right? It would return the procedure object. So it wouldn't be an infinite loop. An application of P would have a value if we took out those parentheses up there. The procedure is P is defined as this. So if you return P, well, it's defined as that. This is the procedure that's being returned.
Can it do that?
Sure.
Why don't you do the same thing that you did here?
Sure. Okay, this is without the parens. Proc, no arguments of P. So it returns P, but it needs to look up what P is. P is a proc of no arguments returning P, and this is the return value. So see here, application of P, here it's just P.
So it's returning like a description of the procedure instead of actually doing this, right?
It's officially returning a pointer to a procedure object. Right. Yes?
If you code that, how do you break out once it starts?
If you code that, I believe a couple of control C's will break it out in Edwin. Yeah. At least probably a couple. It may be one, maybe two or three.
I did two.
Two, is it?
Control G.
No, Control C. Control G is an Emacs stopping command. Control C is a have in the program.
How do we, I can't see where we call the procedure P in test at all. How do we end up going in there?
So P is being passed into test as Y, 0 is going in as X. So this becomes 0, and that becomes a call to P.
And then the call to P, just by having P parentheses there, it knows to go into procedure P?
Well, if we have parentheses around it, we're applying it. Right? So we've got a variable name, we put parentheses around it, we're trying to apply that variable, but hopefully it is a procedure object. Because it's a constant, we're going to have a problem. Okay? So this substitution I just showed you here, where we brought in 0 as X and this parentheses P for Y, would be the normal order substitution. Because recall, if we were doing an applicative order substitution, we would need to actually evaluate those before we substituted them in. And actually, we would never even get into the substitution because we just sit here trying to evaluate there. We just loop.
I think you covered this before, but what would happen? I mean, if P was just a constant that you named P, you defined P3. I think you did this before, but I can't remember.
What would happen if I tried to do apply P?
Yeah, exactly.
Well, let's look at the substitution model. We need to evaluate the sub-expressions, 3, and it tries to apply 3 to nothing, but it can't apply 3 because 3 isn't a procedure object to be applied.
So you just get an error?
You get an error. Maybe it pops into debugger.
It's not entirely clear to me why we don't still get an infinite loop in normal order with our test.
Because we would expand it, and when we try to expand P, wouldn't that still pop us into the infinite loop?
No, because the expansion that we do, let me show you the expansion that we do. Test 0P is going to expand into the body of the lambda with the variable replacement. In this case, if equals 0, 0, 0, otherwise P.
We only evaluate one case.
And because if is a special form, we check the predicate, it's true, we only evaluate the consequent, we never evaluate the alternative.
Okay.
Yes?
So what you're saying is that scheme, even though it uses applicative order, if doesn't.
Scheme uses applicative order, but in
if-
some sense, if we created some scheme application that used normal order, then we could do this and try it out.
But scheme wouldn't have a problem evaluating this.
Oh, scheme would have a huge problem evaluating
But it
this.
would.
Oh, yeah. Because it's applicative order. Applicative order is going to come out with an infinite loop.
I'm not saying that in the case of an if, we would never evaluate.
Okay, so this is normal evaluation, but if still has the same rules, it's still a special form, whether we're using applicative order or normal order. So remember, in applicative order, we're going to evaluate the values of all the sub-expressions first, and then apply the first to the rest, except the case of the 15 special forms. They have their own special rules for evaluation. So they don't fall into applicative or normal order. They're their own special rules.
So if you created your own definition, that would do something a lot like if,
but was it a special form?
Oh, what a beautiful question. What if we were to write our own if? Let's do it. Let's say I'm going to define an if, and I will call it new if to differentiate it, because in fact I cannot say define if. It will give me an error. I can't redefine the special words. So let's define new if to be a lambda that takes in a predicate, a consequence, and an alternative, PCA. Shortened because I don't want to write them all. Okay, well, in our new if, we probably don't want to use if. So let's use cond. Say cond predicate. If the predicate is true, we'll do the consequent. Else, we'll do the alternative. So, let's try it out. New if equals 1, 3, 0, 1. Okay, what happens? Let's follow the substitution model. PC else A. Okay, evaluate this. 3, 1, and equals, which gives us equals. But remember, this is new if, this is not a special form. We actually need to evaluate all of the sub-expressions. And now that we've evaluated all the sub-expressions, we can do our substitution. So predicate, false, consequent, 0, else, alternative, which is our 1. What's the different behavior in our new if? What are we seeing different here than from our special form if? What did I just do? I evaluate the consequent and the alternative, because my new if is not a special form. New if is just a procedure that I've written. So therefore, applicative order applies, our second mantra applies, evaluate all of the sub-expressions. So then we come into our cond. Cond is a special form. It says if we look at the first one, see what its value is. If it's false, then I don't evaluate this. Well, we've actually already evaluated it. We go to the next one. Well, else, that's true. And we return 1. In this case, it doesn't make a great deal of difference. Let's see where it could make a big difference for us. You guys, on problem set 1, saw factorial and corrected it. Fact is lambda n. If n was equal to 0, you return to 1. Otherwise, you returned n times the fact of minus n1. What if we rewrote fact to use new if? Well, let's check it out. Let's try out fact of 1. Prevent us from going through this forever. Fact of 1. This is a 1. This is a procedure of 1 argument, which does new if. Apply this to that. Replace n with 1, which becomes a call to new if. Equals 1, 0, 1, otherwise times 1, fact, minus 1, 1, 2. evaluate sub-expressions in any order. Remember, it's not a special form anymore. This is false. Let's evaluate this one. This is mult. And then this is sub-expression here. We need to do that first. Subtract 1 from 1, which gives us 0. And we're calling the factorial procedure on that 0. Let's expand this. That becomes new if equals 0, 0, return 1, otherwise times 0 fact minus 0n. Sorry, 0, 1. Anybody see any problems we might be running into here?
Yeah, you might have factorial of the minus 1. The fact minus 0.
Okay. We're going to evaluate this. We have to, because this new if is not a special form. When we go to evaluate this, we need to evaluate fact of -1. We have now crashed through our base case. We have no way to get out of this loop. Okay? This is our exit point. We're going to take factorial, say we started at a factorial of 9. We're going to do 8, 7, 6, 5, 4, till we get down to where it's equal to 0. We return a 1 and go back. We'll talk about more on recursive processes and iterative processes in tomorrow's lecture. But in the case where we were using our new if, we get to this point where it's 0, and we should have exited out here. But because of the new if, we're forced to evaluate our alternative. When we're forced to evaluate the alternative, we're trying to evaluate fact of -1, and we spin off into an infinite loop. In other words, it's a good thing that we have special forms.
Is there any way to force new if to do applicative order?
It is doing applicative order. To make it a special form, we can't make it a special form. But we could, I mean, if you wanted to, you could find new if, have if inside of it. But you can't, I mean, then we're not doing anything different, right?
That doesn't work.
That wouldn't,
And that's not going to work either because we're still evaluating these, right? So we really, you don't want to redefine special forms. They have special rules for evaluation for a reason. It makes our life a lot easier.
Going back to the case we were doing before where you had an if and your consequent, or your alternative generated infinite loop.
In this case, our alternative also isn't generating infinite loop, right?
Okay.
We're forced to apply it.
So you said Scheme would have had a problem with that if you were using if.
Okay, in the prior one, the difference came in on whether we were using applicative order or normal order. It came in, the problem came not with the if, but on this call. Because with applicative order, we evaluate that.
Okay.
With normal order, we delay that evaluation until we need it. We were using a special form if, therefore it was never evaluated.
So it's actually kind of the same problem we have right there.
Right, it's kind of the same problem. We just, by rewriting the special form, we created a problem for ourselves because we need to evaluate the stuff going into it.
Okay.
Any other questions?
Wasn't fact already bad because it couldn't take negative numbers?
Huh?
The fact that we had
The fact that you had was bad. I assume that you guys have corrected
No, I
it by
mean,
now. If you
what
haven't,
if
I just gave you
what
the
if
answer.
after fixing we send in a negative number? Wouldn't that without the new if still?
Yes. Oh, yeah. If you pass back to negative number, and in fact, factorial on negative numbers isn't defined anyway.
Oh.
Right. So you probably, most people would be passing back to negative number. If you wanted to error check, you could. You'd add a cons and spit out. We don't do a lot of error checking in Scheme. You can see you spend a lot of time error checking in Scheme. We just simply, using Scheme, you're brilliant, therefore you would have no errors. There you go. Okay, more questions on this stuff?
Is 0 considered a positive integer? I'm just wondering because you could, if it wasn't, then you could have equals n.
I believe
1.
fact of 0 is defined as 1. It's defined. So therefore you'd want that as your base case.
Okay. That will apply to 0 as well.
We think of what? What were you saying?
If you think of factorial n,
as n factorial over n, excuse me, as n plus 1 factorial over n plus 1. That would apply, that would give you the definition for factorial 0 as well.
Other questions?
Yeah, is there some rationale behind not, when you test that to see if n is equal to 0, why don't you just see if n is less than 1? Then you wouldn't have to worry about negative 8.
But then you'll return 1 for a negative value of factorial, and it's not defined. Negative 2 factorial isn't defined. So this is the correct mathematical definition. Right. I guess we're sort of putting the onus on the user to not call it improperly.
If you wanted to error check, if you wanted to have like, I don't know, the conditional being if something is equal to or greater than 0, then you do this. If it's less than 0, then you return a string saying you can't have a factorial that's less than 0.
Sure.
I mean, how would you go about doing a string?
There's a command, if you want to output, I'll show it to you, and we'll use it in problem set 3, but for the most part, you guys should not use this. You should just return the value. Don't start writing out strings. I'll show it to you.
Okay.
But if you start using it, I'll regret it. There's a command called display, and you could display no negative numbers allowed. So in fact, you can output a string, and in problem set 3, we'll be playing a game of 21, and we'll be outputting some strings. And that's the way that we'll do it. For the most part, this isn't like C or Pascal where you want to be outputting stuff like that. You want to be returning just the numbers, the value. You don't want to start doing the stuff. Don't use it. But that's what it is. You don't use it. Yes?
So to fix this thing, could you call factorial with max of 0 and then n minus 1?
Call factorial. That there?
Yeah. But that means if you go down in the negative case, you'll end up at 0.
Except that would still give
You're
you 1 for the negative.
you're still going to
which
loop
is
forever.
false.
Because you're going to keep calling back 0 at that point then. Right? Because you're just going to keep cycling through it anyway. Anything else? You guys have recitation at 1 o'clock today?